Hello, Math 1. Today's topic is graphing day 1. These are just going to be the graphing basics and how we are doing this graphing right now. Of course, it involves the math web. You are either taking this on 10.4.16 or you might be watching this on 10.5.16, but make sure we're following our Cornell Notes format. So you have the topic and the date at the top with a line underneath it. You also have a line going down, giving yourself about 2 to 2.5 inches on the left-hand side for questions in a few days. And of course, vocab bank. We have this thing called the Cartesian plane. Cartesian plane. That's your basic XY coordinate system where we have our y-axes going up and we have our x-axes going horizontal. Okay, it's called the Cartesian plane, so you'll start hear me call it that. And I'll give you guys a little story about the guy who invented this next time I see you. I think we've had this before. It's an ordered pair. This is just an XY coordinate, and we always see it as x's first, then y's. And then we have slope. We call slope the steepness of our graph. It's also called the rate of change. Okay, slope is the steepness of a graph, also known as the rate of change. And then we have this function form of an equation. I put this up on the board, but I want to make sure you guys have it in your notes. And what it is it's that f of x, our outputs, okay, our outputs, f of x, equals the rate times x. Okay, so a rate, any type of rate that we can read in a problem or develop, times x plus a starting amount. These are the equations that we really care about this entire year, is some rate times x plus a starting amount. Okay, our first Roman numeral is Roman numeral 1. And we're looking for the relationship between a table and a graph. And what's going on here is that tables are just organized sets of ordered pairs. So you've seen me building tables in class of where I'm like x, also known as our domain or our inputs, and then y, which is our range or our outputs. And if we have something like 0, 0, 1, 3, 2, 6, 3, 9, and so on and so forth, right? This is just a direct scream to the Cartesian plane. I'm going to graph these guys, give myself a little xy. So here, this says go to where x is 0 and y will be 0 also. I'm going to put a point. This says go to where we have 1 and 3, so I'm going to x is 1 and y is 3, and I'm putting a point. 2 is 6, so the domain of 2 gave me an output of 6, which is up here. And then 3 is 9, so 3 and then 9 is up here. Okay, these are how tables and graphs are connected. Now, the questions I would ask you are, well, is this relationship a function right now? This might be something I would ask you on a test. I would ask you guys to take it from a table, graph it, and then I'd say, is this a function? And of course, just as we use tables to go to graphs, we can use graphs to go to tables. So if we look at this graph here, and we want to describe the relationship in a table, if I go, let's see, x was -2, and the y was -1. As I move across, let's see, 0 as an input has some outputs. In fact, it has 2. So let's see, 0 gave me -1, and 0 gave me 2. As I keep going, did 1 give me any outputs? No, 1 has no outputs. 2 has 2, 3, and then of course 3 has this 3, 2. And then I would ask you again, is this a function? All right, Roman numeral number 2 here is equation to table. And what we can do here, when we have functions like this, we can just start inputting ideas or inputs for x, right? And what comes out is going to be our f of x. So we can use tables to organize different inputs and outputs based off of this equation. So let's see. I'm going to go ahead and input from -2 all the way to +2. I usually like to go for 5 points. 5 points in a table. And I usually like to have some negative numbers and some positive numbers, and I always like to have 0 in there also. So let's go ahead and start going through some of these. This is going to be f of -2 equals 2 times -2 plus 1. The math here says do f of -2 equals, let's see, 2 times -2 is -4 plus 1. So this is going to be -3 as my output. So we want to put this in function notation. So this is f of -2. F of -2 equals -3. I'm going to go ahead and I'll do one more for you, and then I'm going to expect you guys to do the rest and fill out the rest of my table. So let's see, let's do one of the positive numbers. I'm going to put in f of 2. F of 2 equals 2 times 2 plus 1, where I'm taking my input and I'm putting it in for x. Taking my input, putting it in for x. I'm going to do the math that it's asking me to do. This is 4 plus 1, or 5. I'm going to report this in function notation. So f of 2 equaled 4 plus 1. F of 2 equals 5. So that will go right here. You guys go ahead and do the rest, fill out the rest of my table. Of course, the whole reason for this is that if we go from equation to table, once we have a table, we can go table to graph. So as of right now, where we don't know how to graph equations yet, we're just going to use equations to build tables, and from the tables then build the graph. Okay, Roman numeral 3 here is equation to graph. And in Math 1, this is like the big skill that we need to know. I'd say there's 3 major skills to learn in this first semester, and this is definitely top 3 here, okay? So we're going to spend a lot of time with this idea of equation to graph. Right now, I just want to get the basic vocabulary and basic ideas in your head. The first thing is a positive rate or a positive slope, okay? So if you have something tied to that x and it is a positive number, your line should be having some type of positive steepness or positive rate or positive slope. And what that means is that as we move from left to right, the line goes up. Okay, so as we move from left to right, the line goes up in the positive direction. So notice it starts here and it's going up. All these lines right here are examples of positive slope. Of course, when you have positive slope or positive rates, we of course have negative rates and slope. Okay, negative rates and slope, they move down as we go from left to right, or they decrease. So negative rate or negative slope moves down as we move from left to right. And then, of course, we have zero slope or zero rate. And what that's going to look like are these flat lines. Okay, so flat lines such as that has a 0 slope, or that has a 0 slope, or this has a 0 slope. Okay, all these blue lines are examples of 0 slope or no rate of change. There's no rate, so it doesn't go up or go down, it just remains flat the entire time. Make sure you guys have all this down. Make sure you pause and stop and go back and fix anything that you need to fix. And also make sure you guys do the summary of the Say Do What format for functions and MathWeb Cornell notes. That was the last set of notes we took, and it's been about 5 days, so we need to go back, reread them, and do a summary within the Say Do What format. I will see you all tomorrow. Bye.